Looking around the planet, there are a number of medium-sized volcanic cones, the most common of which are cinder cones. Individual volcanoes, of which there are many in the southwestern United States, can have dozens or even hundreds of these features, which generally produce moderately explosive eruptions. For example, the San Francisco volcanic field in Arizona, which produced its last eruption in 1085, contains an estimated 600 cinder cones per the U.S. Geological Survey across an area of 1,800 square miles. However, even when closely spaced, cinder cones tend to be at closest 800 to 1,600 meters from one another. This makes the following location in Iceland all the more unusual. Here, at Lake Mývatn, in the northern section of Iceland, there are more than 1,400 closely spaced volcanic cones which dot the landscape, being as close to one another as 10 to 50 meters apart. For example, while the most number of volcanic cones I could fit in a 300 by 300 meter square in the San Francisco volcanic field was 2. But, adjacent to Lake Mývatn, an example patch of ground of the same size has 27 volcanic cones. This means that in some areas the density of volcanic cones is stunning, measuring in at 300 volcanic cones per square kilometer. However, not everything is what it seems. Although these volcanic cones are natural, you might have noticed that they are smaller than typical cinder cones. And, while being about the same size as some spatter cones, these structures are not spatter cones either. In fact, they are not true vents where magma traveled hundreds or even thousands of meters from an underground magma chamber to the surface. Instead, these are all referred to as rootless cones, which are best described as volcanic cones constructed not directly through a magmatic intrusion, but rather due to the movement and interaction of lava flows with the surrounding landscape on the surface. The various volcanoes in Iceland, including the ones in the central northern half of the country, exist due to two factors. Here, the crust is spreading apart to the east and west as the Eurasian plate is spreading apart from the North American plate. This has created a series of weak points in the crust, and due to the mantle hotspot underlying the country, it sends large volumes of molten rock into the crust. Since the divergent plate boundary represents a path of least resistance, the intrusions sometimes subsequently erupt onto the surface, which over time has formed a chain of volcanoes. Adjacent to Lake Mývatn are two active volcanic complexes, Krafla and Heiðarspordash. Approximately 2,300 years ago, a body of magma advanced upwards, generating a series of earthquakes as it intruded into the crust. This magma eventually trended into a north-to-south direction, involving what eventually became a slightly more than 7,200 meter long intrusion of magma, which was long and thin. Eventually, this magma reached the surface, ejecting lava into the air and creating a series of lava fountains along a several-kilometer chain of activity. As material fell back to the ground, it created dozens of spatter cones. Due to the region's topography, this lava, which had a relatively low viscosity for molten rock, flowed towards the west. When the lava came into contact with the present lake, it generated a series of littoral explosions. Eventually, a brittle lava bench was constructed and active lava channels moved on top of it. However, this ground soon became saturated with water. This water, due to the heat above it, soon flashed to steam and exploded upwards in sections, cutting a hole in the lava tube. This ejected material in a mostly circular radius. This process then repeated several times in the same location until a small volcanic cone known as a rootless cone had formed. Lava flows at one point likely created a bridge which flowed across the lake, but this has most likely since been eroded. By the time the eruption had ended, 220 square kilometers or 85 square miles had been covered in a layer of volcanic rock. Such abundances of littoral cones were only possible due to the unusually large area the lava covered, abundant groundwater, the low viscosity of the lava, largely flat topography, and the large lake which lava encountered. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank this channel's top supporters on YouTube via YouTube members and patrons on Patreon.